Happy Wednesday. Today we're going to pick up with chapter 20 and we are going to talk about the lymphatic system. The lymphatic system is a kind of a fancier word for our immune system. And our immune system is comprised of different types of blood cells and a substance called lymph, which is where we get the idea of lymphatics or the name lymphatic system. And the lymphatic system undergoes lots of different responses in order to help us fight off diseases or, even to help us not get sick at all, or once we do get sick, help us fight it off so that we're only sick for a little while and then we get back to normal. So the first term on this screen is an inflammatory response. Any invasion inside your body causes an inflammatory response, and you can visualize this sometimes. So, and it could be, the inflammatory response could be a response based on something that you're allergic to. It could be because it could happen. That can happen internally. Those of you who have severe allergies know that. It can also happen externally. So you get swollen somewhere or many places on your body, your face, wherever you got stung. But also when you get sick and your body undergoes an inflammatory response internally and you can't see it, but it's still happening. So what that tells your body is once this inflammatory response begins, that rallies your immune system to go to task on whatever is causing this inflammatory response. And the immune system is designed to make you better. That's the way that God designed our bodies, is to help us get well if we do have an inflammatory response, whether it's due to allergy or some sort of antigen that has entered our body, virus, bacteria. We can produce antibodies. And we've talked about these before, but antibodies are what our body produces to get rid of those foreign bodies or those foreign antigens that are trying to have a little party inside of us. Now, the reason is called the lymphatic system is because, and I mentioned this yesterday when you looked at those the lymph vessels that were in the dermis of the skin. So the lymphatic system uses something called lymph, which is a clear liquid, and that transports your antigen fighting cells and proteins through a network of these lymph vessels, and they operate similarly to blood vessels, meaning it's going to carry that liquid through and get to the place where the infection or allergic response is occurring. And this lymph is carrying those important substances to that part of the body so that your body can go on the attack and get rid of these foreign invaders. So we're going to look at the anatomy of the lymphatic system. The first thing is lymph nodes, and these are basically the storage areas of lymph in your body. They're typically located in the trunk, and I'm going to show you a diagram on the next slide, and we'll look at where those lymph nodes are. The thymus is a gland that's located near the heart, and that's where T cells, which are part of your immune system, these types of cells that we watched a video about it on Monday, but that's where the T cells mature and learn what to fight, what they need to get rid of, or what's okay and what to leave alone. So they have to learn, in a sense, what's good and what's bad, what to attack and what not. Then you have a spleen, and that makes those B cells, which help make the antibodies to fight away and fight off any bacterial or viral infection. But then you have to have, so those are the organs and nodules that help make up the lymphatic system. But then on the cellular level, you have macrophages who, and these guys fight antigens in the lymph nodes by grabbing and holding onto them. And then you have lymphocytes, which are lymph cells, cytes meaning cells in the lymph, which are white blood cells that are produced in your bone marrow And those include your B cells and your T cells. So let's look at this diagram. There's the thymus, and there is the spleen. Now let's go back. The thymus, if you remember, here's a good way to remember that. That's where those T cells mature. So thymus starts with the T. So the T cells mature in the thymus. And then here is the spleen. And sorry, spleen doesn't start with a B. So there's no easy way to remember that by letter other than just remember that your spleen is where the B cells are, which go on to make the antibodies that fight the bacteria and the viruses. And then I want to show you all of these areas here, these dark green circular areas. They're in along a few in your lower or around your elbow and a few around your knees and those joints, but mostly around the trunk of your body. So in your right here in your throat, around your armpits, your neck area, right here in your abdomen, and into your groin area. That's where the lymph nodes are mostly located in your body. All right, so you got your spleen, your thymus, the lymph nodes, and then all these green vessels are those lymph vessels that are going to carry the lymph with all these immune system fighting machines going where they need to go. So the main job of the lymphatic system is to fight off antigens. And remember, antigens are just invaders. We typically think of them as bacteria and viruses, but again, it could be a parasite of some sort, you know, the protozoans, things we talked about like with the protists and fungi mini chapter. So you can have a couple types of immunity. You can have active immunity, which is the better form, because the active immunity means that you have made the antibodies yourself and your body is going to be familiar with them because you have made them, and they can keep coming back. If you get exposed to the infection once, twice, 3 times, they'll come back after that. But then passive immunity is a type of immunity that you receive antibodies from something or someone else. So if you received someone else's blood, had a particular antibody already because they've had the disease and you have it and you're struggling to fight it off, you might receive blood from them, which contains the antibody. So that would be the idea of passive immunity. So your body undergoes a couple of types of immune responses. This diagram looks a little bit different than the one in your book, but the one in your book is right here, the cell-mediated immune response. And that's on page 407, and it goes through the steps. I'm going to use this picture, which looks a little bit different, but I think you can probably follow along. So my recommendation is go to page 407 as I talk through this so that you can follow along too. So at step number 1 in your textbook would be, and this one, this is kind of how this diagram is different, but there's really not a step 1 because we do not have step 1 is showing you a cell that's getting invaded by a virus. Your book is calling this the flu virus, so we can go with that, that's fine. So the flu virus is coming into a cell, okay? That's step number 1 in your textbook, and we'll pretend that's right here. So, you know, you've gotten the flu, it's come in through your eyes, your nose, something like that. And your job as a virus is to go find a healthy cell. All right, so you do that and you start infecting the cell and you're happy and free and you feel like you're gonna go do a good number on this person that you've invaded. However, this macrophage finds you. And that looks very similar to step number 2 in your textbook, if you'll notice there. Okay, so what's happening is this, now in this particular situation, the idea is the same. It's showing in your textbook, it's showing how that macrophage engulfs the virus itself. This diagram is showing you how the macrophage, which is probably good. I'm kind of glad you're seeing, because it does both. It can do either or. So in this diagram, it's showing how the macrophage is surrounding the infected cell. So the macrophages would do both. They'll take the virus and try to get rid of it that way, or they'll take your damaged cells and start taking care of those too, because it does no good for your body to hang on to damaged cells. Because if you remember how viruses work, those viruses get into your cells and they reproduce and reproduce and reproduce until your cell can't hold them anymore, and then they explode and send viruses out. So we also need those macrophages to take care of our sick cells for us, so that those sick cells don't go allowing multiple viral explosions essentially into your body, so that they can go infect many, many more cells. So macrophages do either or, take the virus out by itself or take your sick cells out of the way. Either one of those, both are good. So the macrophage is surrounding the virus or infected cell. That's good. Now, this macrophage is going to take you away, and you're going to enter the lymph. So you're going to enter that little clear liquidy substance called lymph, and something else is going to get you. So you see, or you encounter, these helper T cells. And that's also in the textbook diagram. You see those helper T cells. And this is a lymphocyte, and it's going to do a number on you. It's going to start producing these cytokines. So those are proteins which make the cell that you've invaded explode. And what happens with that, you don't want that to happen yet, because you may not have been able to do all the damage you wanted to do. All right, so these proteins make the cell that you've invaded explode, along with others like it. And this lysis happens when any infected cell breaks apart and it kills them, but it's also going to do a number on you, because those helper T cells are also going to send a message to, if you look at in your textbook, if you look at step number 5, it's going to send a message to the lymphocytes, the B cells, that recognize the antigen. So that antigen is now going to be recognized, and more cells are going to be able to fight off you, because they're going to recognize you as not supposed to be there. And so they're going to start making copies so they can recognize you, and they're going to start attacking you more and more and more. But he also sends out this message to the memory T cells, so that and it sends the messages to these T cells, and these memory T cells that say, hey, make a note of this guy, so when it comes back the next time, he'll have no chance. We'll fight him off even sooner, and you won't even get sick from it, because your body will immediately go on the attack instead of having to wait a little while for you to get sick, and then it recognizes it as bad. All right, and then lastly, if you look at step number 7, you have these cute little, almost looks like a little caterpillar here, and you have that too in your diagram in your textbook. Because what happens is, after all of this, the cytokines and memory T cells, you go on and activate your suppressor T cells. And that's good, because you don't want these T cells all hopped up forever. So what happens is these suppressor T cells start to calm down your system. Once the antigen is taken care of, you need to ramp down the immune response. Otherwise, your immune system is going to go haywire, and it can do more damage to you and your healthy cells and start attacking your healthy cells, and you don't want that. So you actually need these suppressor guys to do their job, okay? Now, if those suppressor cells aren't activated, or suppressor cells aren't activated correctly, you get something called an autoimmune response, and many people have autoimmune diseases, which is what happens is you get, like I said, those immune system cells who are used to fighting off don't get suppressed, and they keep fighting and they keep fighting and they keep fighting, and they fight off what's not supposed to be in there. But since they didn't get turned off by the suppressors, they start attacking what should be in your body. And that's what's considered an autoimmune disease, where a person's immune system can't tell what's good and what's bad. And there are ways to treat these, but it's typically a condition that once you have it, you've been diagnosed with it, you have it for the rest of your life. But there are treatments for these. But if you've ever heard of lupus, diabetes is a type of an autoimmune disease. Many allergies are autoimmune disease or can trigger autoimmune responses. Arthritis is an autoimmune disease. Okay, so those are, that's a brief overview of a cell-mediated response. Now there's something called humoral immunity. And that takes place between the cells and relies on fluids that we call humors. And I'm going to go down to this diagram and then we'll come back and talk about vaccination. So I could not find one that matched the one in your textbook, but on page 408, you have this diagram. Okay, that's on page 408. And I'm going to kind of walk through the steps here and compare them to what's in your textbooks with steps 1 through 5. But this is called humoral immunity. So instead of activating the T cells, this process is mostly B cells. Okay. So if you take a look, the way this is going, take this diagram and you can kind of turn it sideways, and that's the way your book goes through this. But these are the antigens up here. So bacteria, viruses, whatever antigen you want to talk about, there it is. So if we want to go back into the idea of the flu. So let's pretend this is the flu again. And this time you've been detected by the immune system in the spaces between the cells, even before you've infected that healthy cell. All right. So you've been spotted. Here we go. It's starting to see you right here. So those B cells start to make more B cells that recognize you, and they're getting ready to make antibodies to attack. Then, if you look at step 3 in your diagram, you've got these B lymphocytes here. So the helper T cells are activated to signal more B cells to make more antibodies. And then you come down to 4, where you have the antibodies, which is kind of like a circular place on your diagram in your textbook. So these antibodies will ride the tide, kind of go with the flow of the lymph or the blood, depending on where this is located, to the site of the infection. And then you're going to come down here. So this is the last place. So this is the far right portion in your textbook. The B cells will make plasma cells, which create more, your book refers to them as wanted posters, but let other parts of your body know, hey, this is the bad guy. This is who we want to seek out. Antibodies is what the bad guy, or what the wanted posters, or the analogy in your textbook, the wanted posters are the antibodies. And then everybody knows to look out for you, and they can keep going on the attack by bringing you in and destroying you. Okay. Notice this word on this down here, this phagocytosis. Do you guys remember what that is? Think about it. Let me know if you have any questions about phagocytosis. Look it up if you're not sure, but we've talked about it before. So how does the immune system react or interact with other parts of the body? Well, it definitely reacts with the skin, because the skin is kind of a buffer from the outside world to inside your body. So your skin is your first line of defense and actually is part of your immune system. You need muscles to push lymph through the vessels. Your bone marrow produces those lymphocytes, which are important, those lymph cells. Then you need the circulatory system to get the blood cells flowing. And then your digestive system also actually helps rid your body of bad things that aren't supposed to be there. All right, that was a whirlwind tour of the lymphatic system. I hope you guys have a great rest of your day.